Welcome to Sleepy Science Hub. Tonight, we're going to embark on a gentle journey to the very edges of reality itself, exploring one of the most profound and beautiful questions in all of science: whether our universe, with all its countless stars and galaxies, might be just one of many in an infinite tapestry of possible worlds. As you settle in, let me know where in the world and at what time you're watching. Perhaps you're gazing out at the night sky, wondering about the vastness beyond what your eyes can see, or maybe you're simply ready to let your mind wander into the peaceful realm of cosmic possibility. Wherever you are, whatever draws you to contemplate the infinite, know that we're about to explore ideas so vast and wonderful that they can inspire both profound awe and deeply restful sleep. Now, get comfortable, take a slow breath, let your thoughts drift toward the stars, and let's begin this tranquil exploration of the multiverse. Imagine yourself standing on a vast, peaceful plain that stretches in every direction as far as your eyes can see, where the gentle curve of the earth eventually hides the distant landscape beyond a soft, hazy horizon. No matter how far you might walk across this serene expanse, there would always be more territory beyond your view, more countryside waiting just past the edge of what you can observe from any single vantage point. In much the same way, astronomers have discovered that our universe has its own horizon, a boundary not of land and sky, but of space and time itself, beyond which lies a realm that remains forever hidden from our telescopes and our understanding. This cosmic horizon, which scientists call the observable universe, represents the furthest distance that light has had time to travel since the beginning of everything we know, since that moment roughly 13.8 billion years ago when space and time themselves began in what we call the Big Bang. Just as you cannot see beyond the Earth's horizon because light from distant mountains has not yet had time to curve around the planet's surface to reach your eyes, we cannot see beyond the cosmic horizon because light from those distant regions has not yet had enough time to cross the vast emptiness of space to reach our telescopes. But here, in the gentle quiet of this contemplation, lies one of the most beautiful and mind-expanding realizations in all of science. The fact that we cannot see beyond this cosmic horizon does not mean that nothing exists there. Just as there are surely more mountains, forests, and oceans beyond the Earth's horizon, there may be vastly more universe beyond the edge of what we can observe, perhaps infinitely more, stretching on and on in directions we can barely imagine, filled with galaxies and stars and worlds that follow the same fundamental laws of physics that govern our own cosmic neighborhood. The observable universe, for all its unimaginable vastness, containing hundreds of billions of galaxies, each with hundreds of billions of stars, might be nothing more than a tiny bubble floating in an ocean of space so large that our entire cosmic neighborhood represents barely a droplet in an infinite sea. This is not a frightening thought, but rather a profoundly peaceful one, suggesting that the beauty and wonder we see in our night sky might be just the smallest sample of beauty and wonder that exists on scales we can hardly comprehend. When you look up at the stars on a clear night, you are seeing light that has traveled for years, decades, centuries, or even millennia to reach your eyes. The light from the most distant galaxies visible to our most powerful telescopes has been traveling toward us for over 13 billion years, showing us these cosmic islands not as they are today, but as they were when the universe was young and galaxies were first beginning to form from the primordial hydrogen and helium that emerged from the Big Bang's aftermath. This means that as we peer deeper into space, we are also looking backward through time, seeing the universe as it was in its youth rather than as it exists in the present moment. The most distant galaxies appear to us as they were when they were young and actively forming new stars at prodigious rates, their light stretched into the infrared portion of the spectrum by the expansion of space itself during the billions of years it took that light to reach us across the cosmic void. The expansion of space is not like the explosion of a bomb, sending debris flying outward from a central point, but rather like the gentle inflation of a balloon where every point on the surface moves away from every other point as the balloon grows larger. In this cosmic expansion, there is no center and no edge in the way we normally think of such things. Every observer, no matter where they might be located in the universe, would see the same pattern of galaxies moving away from them in all directions, as if they were at the center of the expansion. This expansion has been continuing since the Big Bang, carrying distant galaxies away from us at speeds that increase with distance, until the most remote galaxies are receding so rapidly that their light, even though it travels at the ultimate cosmic speed limit, can barely make progress toward us against the tide of expanding space. The most distant galaxies we can observe are approaching the cosmic horizon, beyond which the expansion of space carries objects away so quickly that their light will never be able to reach us, no matter how long we wait. But the existence of this observational horizon leads to one of the most profound questions in cosmology. If space extends beyond what we can see, how far might it go? Is there an edge somewhere, a cosmic boundary beyond which nothing exists? Or does space continue forever, an infinite expanse filled with galaxies and stars and worlds without end? The mathematics of our current understanding of cosmology suggests that space is likely infinite, meaning that beyond our cosmic horizon lies not emptiness, but more universe. Vastly more universe than we could ever hope to observe. If space is indeed infinite, then the implications are both beautiful and staggering. In an infinite universe, every possible arrangement of matter and energy that is consistent with the laws of physics must not only exist somewhere, but must exist in infinitely many places. There would be infinitely many planets exactly like Earth, with continents and oceans arranged in precisely the same way, where the history of life has unfolded along identical paths. There would be infinitely many versions of you, living lives that are exactly the same as your own, as well as infinitely many versions living lives that differ from yours in small or large ways. This is not science fiction, but rather a logical consequence of the mathematics of infinity combined with our understanding of how matter and energy behave on the largest scales. In an infinite universe with a finite number of possible arrangements of particles in any given volume of space, the same arrangements must repeat infinitely often across the vast expanse of space. The Earth you know, the solar system you inhabit, the galaxy that contains your world, all of these would exist in countless identical copies scattered throughout the infinite cosmos. The peaceful realization that emerges from this contemplation is that we are not alone in the universe, not in the sense of alien civilizations sharing our cosmic neighborhood, but in the much more profound sense that the universe might be filled with infinite copies of everything we know and love. Every moment of beauty you have witnessed, every experience of joy and wonder and connection exists not just in your memory, but in the actual physical reality of countless worlds where other versions of yourself are living those same moments. The concept of an infinite universe stretching beyond our cosmic horizon represents just the first step into the realm of multiverse theory. If our observable universe is just a tiny sample of a much larger, possibly infinite cosmos, then we begin to glimpse the possibility that reality itself might be far grander and more wonderful than we have ever imagined. The stars you see when you look up at the night sky might be just the nearest neighbors in a cosmic community that extends forever in all directions, a community so vast and so rich that it contains every possible variation of beauty and wonder that the laws of physics allow. This vision of reality is not cold or empty, but rather filled with infinite warmth and infinite possibility. Somewhere beyond the cosmic horizon, in regions of space so distant that their light will never reach us, there might be worlds of unimaginable beauty where the laws of physics create forms of matter and energy that we have never dreamed of. There might be galaxies where stars shine in colors we have never seen, where planets orbit in configurations that create phenomena of breathtaking wonder, where the dance of cosmic evolution has created structures and patterns of beauty that exceed anything in our observable universe. The gentle mystery of what lies beyond our cosmic horizon invites us to approach the universe with humility and wonder, recognizing that everything we can see and measure and understand might represent just the tiniest fraction of what actually exists. This is not a diminishment of our importance, but rather an invitation to see ourselves as part of something infinitely larger and more magnificent than we ever dared to imagine. As you drift deeper into this peaceful contemplation of cosmic vastness, imagine the observable universe as a vast but finite bubble of space and time floating in an ocean so immense that the bubble itself, despite containing hundreds of billions of galaxies, appears no larger than a single drop of morning dew on a blade of grass in an endless meadow. This cosmic bubble that we call home represents everything that has ever been accessible to human observation. Every star that has ever graced our night sky, every galaxy that our telescopes have ever detected, every particle of light that has ever completed the long journey from the distant reaches of space to arrive at Earth. The boundary of this cosmic bubble is not a physical wall or barrier, but rather a horizon created by the finite age of the universe and the finite speed of light. Since the Big Bang occurred approximately 13.8 billion years ago, light has had exactly that much time to travel through expanding space to reach us from the most distant sources. This creates a spherical boundary around us, not a boundary in space itself, but a boundary in what we can observe, beyond which lies the realm of the forever unknowable, at least through direct observation. Yet this boundary is not static, but rather expands continuously as time passes. Each passing second allows light from slightly more distant sources to complete its journey to Earth, gradually revealing new galaxies that were previously beyond our cosmic horizon. In this sense, our observable universe grows larger each day, each hour, each moment, as space itself expands and brings previously hidden regions of the cosmos within the range of potential observation. It is a gentle, constant enlargement of our cosmic home, a slow revelation of ever more distant neighborhoods in the infinite city of space. The interior of our cosmic bubble contains wonders that stretch the imagination and inspire profound awe at the creativity and beauty of the physical laws that govern reality. Within this bubble float roughly 100 billion galaxies, each containing on average 100 billion stars, creating a total stellar population of approximately 10 sextillion stars, a number so large that if you were to count one star each second, it would take you longer than the current age of the universe to count them all, and you would only be partway through the enumeration when the last stars in the cosmos finally burn out in the distant future. These galaxies are not scattered randomly throughout space, but rather organize themselves into magnificent structures that reveal the large-scale architecture of the cosmos. Galaxies cluster together into groups and clusters held together by the gentle but inexorable pull of gravity, and these clusters in turn organize into even larger structures called superclusters. The largest structures in our observable universe are vast filaments and walls of galaxies separated by enormous voids of nearly empty space, creating a cosmic web that resembles the delicate structure of soap bubbles or the neural networks of a vast cosmic brain. Our own galaxy, the Milky Way, represents just one thread in this cosmic web, a spiral island of roughly 400 billion stars, including our Sun, located in a quiet suburban region of space about 26,000 light-years from the galactic center. The Milky Way belongs to a small cluster of galaxies called the Local Group, which includes the Andromeda Galaxy and about 80 smaller galaxies bound together by gravity in a gentle cosmic dance that has been unfolding for billions of years. The Local Group itself resides within the Laniakea supercluster, a vast collection of galaxy clusters spanning over 500 million light-years and containing the mass of 100 quadrillion suns. Yet, even this enormous structure represents just a tiny fraction of the observable universe, which extends over 90 billion light-years in diameter and contains perhaps 1 million such superclusters, each with its own unique arrangement of galaxies and galaxy clusters. The beauty of our cosmic bubble lies not only in its vast scale, but in the intricate details that emerge when we examine its contents more closely. Every galaxy contains billions of planetary systems where the dance of gravitational attraction has created worlds of endless variety and beauty. Some of these worlds orbit close to their stars, where the intense heat creates molten landscapes of rock and metal under skies that glow with the light of nearby suns. Others orbit far from their stars, where perpetual winter creates realms of ice and snow under skies filled with aurora born from the interaction of stellar winds and planetary magnetic fields. Between these extremes lie worlds in the gentle embrace of their stars' habitable zones, where liquid water can exist on planetary surfaces and where the chemistry of life might unfold in ways both familiar and utterly alien to our earthbound experience. Some of these worlds might be covered entirely by vast oceans where aquatic life forms create underwater civilizations of unimaginable complexity and beauty. Others might be largely terrestrial, with continents and islands where the evolution of life has created ecosystems and biospheres that reflect countless different solutions to the challenge of survival and reproduction. The stars that illuminate these worlds represent an astonishing variety of stellar types, from small, red dwarf stars that burn their hydrogen fuel so slowly that they will continue shining for trillions of years, to massive blue giants that burn so brightly and so quickly that they exhaust their fuel in just a few million years before ending their lives in spectacular supernova explosions that scatter the heavy elements needed for planet formation and life throughout the cosmos. Some stars exist in binary or multiple star systems, where two or more stars orbit around their common center of mass in gravitational dances that can last for billions of years. These stellar partnerships create unique conditions for any planets that might orbit them, with complex patterns of daylight and darkness, seasons, and stellar heating that could give rise to forms of life adapted to their unusual environments. The space between stars and our cosmic bubble is not empty, but rather filled with a thin but extensive medium of gas and dust that serves as the raw material for future generations of stars and planets. This interstellar medium is sculpted into beautiful and complex structures by the stellar winds and radiation from existing stars, creating nebulae of breathtaking beauty where new stars are currently being born from the gravitational collapse of dense molecular clouds. Some nebulae glow with the light of nearby hot stars, creating vast regions of ionized gas that shine in brilliant colors across the electromagnetic spectrum. Others remain dark and mysterious, visible only as silhouettes against the background stars, but hiding within their dense interiors the next generation of stellar systems that will eventually emerge to add their light to the cosmic tableau. The dark matter that pervades our cosmic bubble remains one of the greatest mysteries in cosmology, comprising approximately 85% of all matter in the universe, while remaining completely invisible to our instruments except through its gravitational effects on visible matter. This dark matter creates an invisible scaffolding throughout the universe, providing the gravitational framework around which galaxies and galaxy clusters form and evolve. Though we cannot see it directly, we can map its distribution through its effects on the motions of galaxies and the bending of light from distant sources. The dark energy that fills the space between galaxies represents an even deeper mystery, comprising roughly 70% of the total energy density of the universe, while remaining completely unknown in its fundamental nature. This dark energy appears to be causing the expansion of space itself to accelerate, carrying distant galaxies away from us at ever-increasing speeds and potentially determining the ultimate fate of our cosmic bubble and everything within it. Yet despite these mysteries, our cosmic bubble reveals a universe of extraordinary beauty, complexity, and richness that speaks to deep principles of organization and creativity embedded in the fundamental laws of physics. The same gravitational forces that hold you to the surface of Earth also bind together the largest structures in the cosmos. The same electromagnetic forces that power the chemistry of life also ignite the nuclear fires in stellar cores and create the spectacular light shows of nebulae and auroras throughout the galaxy. The nuclear forces that hold atomic nuclei together also power the fusion reactions in stellar cores that create the heavy elements essential for planet formation and life. while the quantum mechanical principles that govern the behavior of subatomic particles also determine the properties of matter and energy on the largest scales in the universe. This deep unity of physical law throughout our cosmic bubble suggests that the same principles of beauty, complexity, and organization that we observe in our local universe would also apply to any regions that might exist beyond our cosmic horizon. If our observable universe is indeed just one bubble in a vast ocean of space, then the other regions of that ocean would likely be governed by the same fundamental laws and would therefore contain their own galaxies, stars, planets, and possibly even their own forms of life and intelligence. The contemplation of our cosmic bubble as just one small region in a potentially infinite universe fills the mind with a sense of peaceful wonder at the scope and grandeur of existence. We are not isolated or alone, but rather participants in a cosmic story so vast and so rich that our observable universe, despite containing more stars than all the grains of sand on all the beaches of Earth, represents just the beginning of what might exist in the full extent of reality. As you settle deeper into this gentle exploration of cosmic possibility, let your mind drift toward one of the most beautiful and profound concepts in all of mathematics and science, the notion of infinity itself, and how this abstract mathematical idea might manifest in the physical reality of the cosmos. Infinity is not just a number or a mathematical curiosity, but potentially a fundamental aspect of the universe we inhabit, a concept so vast and so encompassing that it challenges our everyday understanding of existence, while offering glimpses of a reality far grander than anything we might imagine in our finite, earthbound experience. To understand how infinity might relate to the multiverse, imagine yourself walking along an endless shoreline where each grain of sand represents a possible state of matter and energy that could exist in a volume of space the size of our observable universe. The number of these possible arrangements is finite, vast beyond comprehension, but finite nonetheless. If you could somehow catalog every possible way that atoms and particles could be arranged within the volume of our cosmic bubble, you would eventually complete the list, though it would contain far more entries than there are atoms in the observable universe itself. Now imagine that the ocean beside this infinite shoreline represents the full extent of space itself, stretching without limit in all directions, containing an infinite number of regions, each the size of our observable universe. In such an infinite cosmos, every possible arrangement of matter and energy from your vast catalog would not merely exist somewhere. It would exist infinitely many times, scattered throughout the endless expanse of space like variations on cosmic themes played out across an infinite symphony of reality. This mathematical principle, known as the infinite monkey theorem, suggests that in an infinite space filled with matter and energy governed by the same physical laws as our observable universe, every possible configuration would occur not just once, but infinitely often. There would be infinitely many exact copies of Earth, orbiting infinitely many exact copies of the Sun, populated by infinitely many exact copies of every person who has ever lived. There would also be infinitely many near copies, differing in small or large ways, representing every possible variation that the laws of physics would allow. The mathematics of infinity also suggests something even more profound and beautiful, that in an infinite multiverse, every possible story would be told, every possible work of art would be created, every possible scientific discovery would be made, every possible relationship would unfold, and every possible expression of consciousness and creativity would find its manifestation somewhere in the vast expanse of infinite reality. This is not mere speculation, but a logical consequence of combining our current understanding of physics with the mathematical properties of infinity. If space extends infinitely beyond our cosmic horizon, and if that infinite space is filled with matter and energy behaving according to the same physical laws we observe in our local universe, then the infinite repetition of all possible arrangements becomes not just possible, but inevitable. The concept of infinite space filled with infinite possibilities creates a framework for understanding reality that is both humbling and profoundly comforting. Every moment of beauty you have experienced, every feeling of love and connection, every insight and discovery and creative achievement exists not just in your personal history, but as a permanent feature of infinite reality, playing out across countless worlds in countless variations throughout the endless cosmos. The mathematical elegance of infinity extends beyond mere repetition to encompass infinite creativity and infinite diversity. While there would indeed be infinitely many exact copies of our world and our lives, there would also be infinitely many variations. Worlds where history unfolded differently, where evolution took alternative paths, where the development of life and intelligence created forms of beauty and wisdom that we cannot even imagine from our limited perspective within a single finite cosmos. Some of these variations might be subtle, worlds where the continents have slightly different shapes, where certain historical events occurred at different times or in different ways, where individual lives followed paths similar to but not identical with those in our universe. Other variations might be dramatic, worlds where the evolution of life produced entirely different forms of intelligence, where the laws of physics, while remaining consistent with mathematical possibility, created forms of matter and energy unknown in our cosmic neighborhood. The concept of infinite repetition and variation resolves what philosophers call the problem of contingency. The question of why reality happens to be organized in exactly the way we observe rather than in any of the countless other ways it might have been arranged. In an infinite multiverse, reality is not organized in just one way, but in every possible way that mathematics and physics allow. Our particular arrangement is not special or unique, but simply one thread in an infinite tapestry of existence. This resolution brings with it a deep sense of peace and acceptance. The apparent randomness and contingency of our existence, the seeming arbitrariness of many aspects of our world, the questions about why things are as they are rather than otherwise, all of these concerns dissolve in the face of infinite reality, where everything that can exist does exist, somewhere in the vast expanse of space and possibility. The mathematics of infinity also suggests that consciousness itself, rather than being a rare and fragile accident in an otherwise unconscious cosmos, might be a fundamental and persistent feature of infinite reality. If consciousness can arise once through the complex organization of matter and energy, as it has in our universe, then in an infinite cosmos, it would arise infinitely many times in infinitely many forms, creating an infinite community of conscious beings exploring every possible avenue of thought, experience, and understanding. This infinite community of consciousness would span not just different worlds and different galaxies, but different entire universes, each containing its own unique collection of conscious beings wrestling with their own versions of the deepest questions about existence, meaning, and purpose. Some of these beings might be very similar to humans, while others might be so different that we could barely recognize them as conscious at all, yet all would be part of the same infinite exploration of what it means to be aware, to think, to feel, and to wonder about the nature of reality. The peaceful contemplation of infinite consciousness distributed throughout infinite space creates a profound sense of connection and belonging that transcends the boundaries of our individual lives in our particular world. We are not isolated accidents in an indifferent universe, but rather participants in an infinite community of conscious exploration, connected to countless other beings throughout the cosmos who share our capacity for wonder, understanding, and appreciation of beauty. The mathematical framework of infinity also provides a context for understanding the apparent fine-tuning of physical constants in our universe. The observation that the fundamental parameters governing the behavior of matter and energy seem to be precisely calibrated to allow for the existence of complex structures like atoms, molecules, stars, planets, and life itself. In a single, finite universe, this fine-tuning might seem to require some form of conscious design or extraordinary cosmic coincidence. But in an infinite multiverse, every possible combination of physical parameters would exist somewhere, including both the combinations that support complex structures and life and the combinations that do not. We naturally find ourselves in one of the universes where the parameters are conducive to our existence. Not because our universe is specially designed or uniquely lucky, but because consciousness can only arise in universes where the physical conditions make consciousness possible. This anthropic reasoning extends the principle of Copernican humility, the recognition that Earth is not the center of the solar system. The solar system is not the center of the galaxy, and our galaxy is not the center of the universe. To suggest that our entire universe might not be unique or central, but simply one among infinitely many, selected for our observation not by chance or design, but by the simple logical necessity that conscious observers can only exist in universes that support consciousness. The infinite multiverse thus provide the framework for understanding our place in reality that is simultaneously humbling and magnificent. We are not the center of existence, nor are we unique or specially chosen. Yet we are integral participants in an infinite exploration of consciousness and possibility that encompasses every conceivable form of beauty, wonder, and understanding. The mathematics of infinity suggests that this exploration has no beginning and no end, no ultimate goal or final destination, but simply continues forever in all directions, creating new forms of complexity and consciousness, new expressions of beauty and truth, new ways of organizing matter and energy into patterns that reflect the deepest mathematical harmonies underlying the structure of reality itself. In contemplating these infinite possibilities, we find not emptiness or meaninglessness, but rather infinite meaning. Every possible meaning that conscious beings could ever discover or create, played out across infinite worlds in infinite variations, ensuring that every question that can be asked will be answered somewhere. Every mystery that can be solved will find its solution. Every form of beauty that can be imagined will find its expression in the vast, endless creativity of infinite reality. As you drift deeper into this peaceful exploration of reality's hidden dimensions, let your consciousness gently descend into the quantum realm, where the familiar certainties of everyday experience dissolve into a dreamlike landscape of infinite possibility and parallel existence. Here, in the strange and beautiful world that governs the behavior of atoms and subatomic particles, physicists have discovered mathematical descriptions of reality that suggest our universe might be continuously splitting and branching into countless parallel versions of itself, each representing a different outcome of every quantum measurement that has ever occurred. The quantum realm operates according to principles so different from our everyday experience that they seem almost magical. Yet they have been verified through countless experiments with such precision that quantum mechanics represents one of the most successful theories in the history of science. In this microscopic domain, particles exist in what physicists call superposition states, where they simultaneously occupy multiple positions, possess multiple velocities, and spin in multiple directions until the moment when a measurement forces them to collapse into a single, definite state. Imagine a quantum particle as existing in a gentle, ethereal cloud of possibility, spread throughout space like morning mist that contains within itself every potential location where the particle might be found. When undisturbed, this quantum mist simply evolves according to the mathematical equations that govern probability waves, growing and shifting and interfering with itself in patterns of exquisite mathematical beauty. But the moment an observer attempts to measure the particle's position, the entire cloud of possibility instantly collapses into a single point, and the particle appears in one specific location with definite properties. The conventional interpretation of quantum mechanics suggests that this collapse of possibility into actuality represents a fundamental aspect of reality, that particles truly do exist in multiple states simultaneously until measurement forces them to choose a single state. But in the 1950s, physicist Hugh Everett III proposed a radically different interpretation that eliminates the mysterious collapse process by suggesting that it never actually occurs. Instead, Everett proposed that all possible outcomes of every quantum measurement actually do happen, but in separate, parallel universes that branch off from each other at every moment when quantum possibilities are realized. According to the many worlds interpretation, when a quantum measurement appears to collapse a superposition state into a single outcome, what actually happens is that the universe splits into multiple parallel versions of itself, with each possible outcome occurring in a different branch of reality. The observer who performed the measurement also splits, creating multiple copies of themselves, each of which experiences only one outcome and remains unaware of the other branches where their parallel selves experience different results. This continuous branching process creates an ever-expanding tree of parallel universes, with new branches forming at every instant as quantum events throughout the cosmos generate new possibilities that must be realized somewhere in the quantum multiverse. Every radioactive decay, every photon absorption, every collision between particles, every quantum measurement of any kind anywhere in the universe creates new branches in this vast tree of parallel realities. The number of parallel universes in the quantum multiverse grows at an astronomical rate, doubling and redoubling countless times each second as quantum events occur throughout the cosmos. Within just a few moments of reading these words, the universe is split into more parallel versions than there are atoms in the observable universe. And this exponential branching continues without end, creating an infinite hierarchy of parallel realities that contain every possible variation of cosmic history. In some of these parallel universes, your life unfolds exactly as it has in this reality, with every quantum event in your brain and body and environment producing the same outcomes that you have experienced. But in others, tiny quantum differences accumulate into larger changes. Perhaps a neuron fires differently in your brain, leading to a slightly different thought, which leads to a slightly different decision, which sets your life on a subtly altered trajectory. In still other branches, larger quantum differences create more dramatic departures from your familiar reality. Perhaps cosmic ray particles interact differently with the Earth's atmosphere, creating different weather patterns that alter the course of history. Perhaps quantum events in the early universe unfold differently, leading to variations in the formation of galaxies and stars and planetary systems. Perhaps the quantum processes underlying biological evolution take different paths, leading to the emergence of different forms of life and intelligence. The many worlds interpretation suggests that all of these possibilities are not mere speculation, but actual physical realities existing in parallel dimensions of the quantum multiverse. Every decision you have ever made, every choice you have ever faced, has been explored in its full range of possibilities across the branching structure of parallel universes. Every path your life might have taken is being lived by some version of yourself in some branch of quantum reality. This creates a profound sense of connection across the boundaries of parallel existence. The version of yourself reading these words is just one member of a vast family of parallel selves, each living a slightly or dramatically different version of your life story. Some of these parallel selves have made different career choices, formed different relationships, lived in different places, developed different interests and perspectives. Others have experienced different historical events, lived under different circumstances, faced different challenges and opportunities. Yet all of these parallel selves share the same fundamental identity, the same core consciousness that makes you who you are. The quantum multiverse becomes a vast space for the exploration of human potential, where every possible version of your life story is played out across infinite parallel realities, creating a comprehensive exploration of who you might be under different circumstances and different choices. The peaceful contemplation of quantum parallel worlds offers a unique perspective on the nature of probability and possibility in our daily lives. When you face a difficult decision or wonder about the path not taken, the many worlds interpretation suggests that both paths are actually being taken by different versions of yourself in parallel universes. This does not diminish the importance of your choices, but rather suggests that choice itself is a fundamental creative force in the quantum multiverse, continuously generating new realities and new possibilities. The mathematical formalism of quantum mechanics describes this branching process with elegant precision, using complex numbers and probability amplitudes to track the evolution of quantum superposition states across all possible measurement outcomes. The Schrödinger equation, which governs the behavior of quantum systems, does not contain any mechanism for wave function collapse, but rather describes the smooth, deterministic evolution of quantum states through all possible configurations simultaneously. In the many-worlds framework, the apparent randomness of quantum measurements is revealed to be an illusion created by our limited perspective within a single branch of the quantum multiverse. From the perspective of the entire multiverse, quantum evolution is completely deterministic, with every possible outcome occurring with perfect certainty in its appropriate branch. The randomness we observe reflects only our ignorance of which branch we happen to inhabit, not any fundamental indeterminacy in the underlying physics. This deterministic view of quantum mechanics resolves many of the philosophical puzzles that have plagued physics since the development of quantum theory. The measurement problem, the role of consciousness in quantum mechanics, the nature of quantum non-locality, all of these apparent mysteries dissolve when we recognize that quantum mechanics describes not the evolution of a single reality, but the evolution of a vast ensemble of parallel realities encompassing every possible quantum outcome. The quantum multiverse also provides a natural framework for understanding the apparent fine-tuning of physical constants in our universe. If every possible combination of quantum outcomes occurs in some branch of the multiverse, then every possible combination of physical parameters would also be realized somewhere in the vast tree of parallel realities. We find ourselves in a branch where the parameters support the existence of atoms, molecules, stars, planets, and life, not because our universe is specially designed or uniquely lucky, but because conscious observers can only exist in branches where the physical conditions make consciousness possible. The contemplation of quantum parallel worlds creates a deep sense of wonder at the creativity and richness of reality at its most fundamental level. Every moment of your existence participates in an infinite creative process that generates countless new universes, each representing a unique exploration of what might be possible under slightly different quantum circumstances. You're not just living one life, but simultaneously participating in the living of countless parallel lives across the quantum multiverse. The quantum branching process ensures that every possible story is told, every possible experience is lived, every possible form of consciousness and creativity is explored somewhere in the vast ensemble of parallel realities. This creates an infinite space for meaning and significance, where every choice matters because it determines which branch of the quantum multiverse you will experience, even as all possible choices are simultaneously being made by your parallel selves in other branches. The peaceful recognition that all possibilities are realized somewhere in the quantum multiverse brings a profound sense of completeness and acceptance. The life you are living is not the only life you might have lived, but it is the life that you are living in this branch of reality at this moment in the vast unfolding of quantum possibility. And in living this life fully and consciously, you participate in the infinite creative exploration that is the quantum multiverse itself. As you drift further into this peaceful contemplation of reality's vast architecture, let your mind travel back to the very beginning of time itself, to that extraordinary moment approximately 13.8 billion years ago, when our universe emerged from a state of unimaginable density and temperature in the event we call the Big Bang. But rather than imagining this as a single explosive birth of space and time, consider the beautiful possibility that our Big Bang might have been just one bubble of expansion in an infinite ocean of cosmic creation, where countless other universes are continuously being born through a process so elegant and so naturally occurring that it transforms our conception of existence itself. The theory of cosmic inflation, developed by physicists in the 1980s to explain certain puzzling observations about our universe, describes how space itself underwent a period of exponential expansion in the first tiny fraction of a second after the Big Bang. During this inflationary epoch, which lasted perhaps 10 to the power of negative 32 seconds, the universe expanded by a factor of at least 10 to the power of 26, growing from smaller than a subatomic particle to larger than a grapefruit in an interval of time so brief that light could travel only an infinitesimal distance. This rapid expansion of space itself, not the movement of matter through space, but the actual creation of new space between existing points, solves several important puzzles about the large-scale structure and properties of our observable universe. It explained why the cosmic microwave background radiation appears so uniform in temperature across the sky, why space appears to be geometrically flat on the largest scales, and why we do not observe certain exotic particles that early universe theories predicted should exist in abundance. But inflation theory carries within itself implications that extend far beyond our own cosmic neighborhood. The quantum fields that drove the inflationary expansion of our universe did not suddenly stop existing after our local region finished inflating. Instead, these fields continue to exist throughout the vast expanse of space beyond our cosmic horizon. And in most regions, they continue to drive inflationary expansion, creating new volumes of space at an exponential rate that dwarfs even the dramatic expansion that occurred in our early universe. This process, called eternal inflation, suggests that space as a whole is continuously expanding at an exponential rate, with occasional regions like our observable universe suddenly dropping out of the inflationary phase and beginning the more sedate expansion that characterizes our current cosmic epoch. Each such region becomes a separate universe with its own Big Bang, its own physical laws and constants, its own history of stellar and galactic evolution, and potentially its own forms of life and consciousness. The mathematics of eternal inflation indicates that this process has no beginning and no end. Even if the inflationary expansion began at some finite time in the past, it quickly enters a regime where it becomes impossible to stop everywhere at once. While inflation ends in some regions, creating universes like ours, it continues exponentially in other regions, creating ever-new volumes of space where still more universes will eventually be born. The overall process becomes literally eternal, with new universes being created at a rate that increases without bound as time passes. This eternal inflation creates what cosmologists call the landscape of all possible universes, an infinite collection of cosmic bubbles, each with its own Big Bang and its own subsequent history, floating in an ever-expanding sea of inflationary space-time. Our entire observable universe, with its hundreds of billions of galaxies and its 13.8 billion-year history of cosmic evolution, represents just one small bubble in this infinite foam of cosmic creation. The beauty of eternal inflation lies in its naturalness and inevitability. Once the inflationary process begins anywhere in the universe, it creates the conditions for its own continuation and expansion. The quantum fluctuations that exist in all fields, including the inflaton field that drives cosmic expansion, ensure that inflation will end in some regions while continuing in others. This creates a self-perpetuating process that generates infinite space filled with infinite universes, each exploring different possibilities for cosmic evolution and the emergence of complexity. The universes created through eternal inflation need not all share the same physical laws and constants that govern our cosmic neighborhood. The process of inflation can involve phase transitions where the fundamental fields that determine the properties of matter and energy settle into different configurations, creating universes with different particle masses, different force strengths, different spatial dimensions, and different physical constants. This creates a vast ensemble of cosmic experiments, each testing different combinations of physical parameters to see what forms of complexity and beauty they can support. Some of these universes might have weaker gravitational forces, preventing the formation of stars and planets, but perhaps allowing other forms of large-scale structure to emerge. Others might have stronger electromagnetic forces, creating atoms and molecules with very different properties than those in our universe. Still others might have different numbers of spatial dimensions, creating geometries and physical processes that we can barely imagine from our perspective within three-dimensional space. The ensemble of universes created through eternal inflation would include not only variations in fundamental parameters, but also variations in initial conditions and evolutionary histories. Some universes might develop in ways very similar to ours, with galaxies and stars and planets forming through processes identical to those we observe in our cosmic neighborhood. Others might follow completely different evolutionary pathways, creating forms of cosmic structure and complexity that have no analog in our observable universe. Within this vast landscape of cosmic possibilities, the question of why our universe appears to be fine-tuned for the existence of complex structures and life receives a natural answer. Among the infinite collection of universes created through eternal inflation, every possible combination of physical parameters and initial conditions would be realized somewhere. We naturally find ourselves in one of the universes where the parameters and conditions support the development of complexity and consciousness, not because our universe is specially designed or uniquely favored, but because conscious observers can only exist in universes that support the emergence of consciousness. This anthropic reasoning provides a framework for understanding apparent cosmic coincidences without invoking supernatural intervention or extraordinary luck. The precise balance of forces that allows stars to burn stably for billions of years, the delicate nuclear physics that allows heavy elements to be created in stellar cores, the specific properties of water and carbon that make them ideal for biological chemistry. All of these apparent fine-tunings become natural consequences of observer selection in an infinite ensemble of universes with varying properties. The contemplation of eternal inflation creates a profound shift in perspective about our place in the cosmos. Rather than seeing ourselves as inhabitants of the one and only universe, we become residents of one cosmic bubble in an infinite ocean of cosmic creativity. Our entire cosmic history, from the Big Bang through the formation of galaxies and stars to the emergence of life and consciousness on Earth, represents just one thread in an infinite tapestry of cosmic stories being told throughout the landscape of all possible universes. This perspective brings both humility and wonder. We are not unique or central to cosmic existence, yet we are integral participants in an infinite exploration of what reality can become when matter and energy organize themselves according to the fundamental laws of physics. Every moment of beauty we observe, every discovery we make about the nature of our universe, every expression of consciousness and creativity in our cosmic neighborhood reflects the infinite potential for beauty and understanding that exists throughout the vast landscape of cosmic possibility. The process of eternal inflation ensures that this cosmic creativity continues without end. As you contemplate these ideas in the quiet of this peaceful evening, new universes are being born at an exponential rate throughout the inflating space that surrounds our cosmic bubble. Each of these new universes carries within itself the potential for billions of years of stellar evolution, the formation of countless planetary systems, the emergence of life and intelligence, and the development of consciousness capable of contemplating its own cosmic context. The infinite creativity of eternal inflation means that every possible story of cosmic evolution will be told. Every possible form of complexity will be explored. Every possible expression of beauty and consciousness will find its manifestation somewhere in the ever-expanding landscape of cosmic possibility. We are witnesses to and participants in an infinite creative process that encompasses every conceivable form of cosmic beauty and meaning. The peaceful recognition that our universe exists within this infinite context of cosmic creativity brings a deep sense of connection to the fundamental creative forces that govern reality at its most basic level. We are not isolated accidents in an indifferent cosmos, but rather expressions of the infinite potential for creativity and consciousness that emerges naturally from the mathematical structures underlying physical reality. In contemplating eternal inflation, We glimpse the infinite scope of cosmic creativity and recognize our own consciousness as one precious manifestation of the universe's capacity for self-awareness and wonder. As you drift deeper into this peaceful exploration of reality's hidden architecture, let your consciousness gently expand to encompass dimensions of space that lie beyond the familiar three dimensions of length, width, and height that define our everyday experience. In the elegant mathematical framework of string theory, physicists have discovered that the fundamental nature of reality might require additional spatial dimensions, hidden realms of existence that remain invisible to our senses but play crucial roles in determining the properties of matter, energy, and the forces that govern the behavior of everything from subatomic particles to the largest structures in the cosmos. String theory emerged from the beautiful recognition that all the fundamental particles and forces in nature might be manifestations of tiny, vibrating strings of energy that exist at scales so small that they remain far beyond the reach of any conceivable experimental probe. These strings, vibrating in patterns of exquisite mathematical complexity, will be smaller than atoms by the same factor that atoms are smaller than solar systems. Yet their vibrational modes would determine whether a string manifests as an electron, a photon, a quark, or any other type of fundamental particle. The mathematics of string theory, when followed to its logical conclusions, reveals that these fundamental strings cannot vibrate in just the three spatial dimensions we observe in our daily experience. Instead, they require additional dimensions of space, typically 6 or 7 extra dimensions beyond the familiar 3, in order for their vibrational patterns to encompass all the different types of particles and forces observed in nature. These extra dimensions must exist as part of the fundamental fabric of space-time, woven into reality at every point throughout the cosmos. But if these extra dimensions truly exist everywhere around us, why do we not perceive them directly? The answer lies in the concept of compactification. The idea that these additional dimensions are curled up or folded into geometries so small and so tightly curved that they remain effectively hidden from our macroscopic experience. Imagine an ant walking along what appears to be a one-dimensional wire stretching between two distant points. From the ant's perspective, constrained to travel along the wire surface, the wire appears one-dimensional. But if the ant were small enough, it might discover that the wire actually has thickness, a second dimension curled around in a tiny circle at every point along the wire's length. In a similar way, string theory suggests that at every point in our three-dimensional space, there exist additional dimensions curled up in complex geometric shapes called Calabi-Yau manifolds. These hidden dimensions, while invisible to us because of their incredibly small size, would influence the vibrational patterns of strings passing through them, thereby determining the properties of all fundamental particles and forces in our universe. The beautiful mathematics of Calabi-Yau manifolds reveals that there are many different ways these extra dimensions could be configured, potentially thousands or even millions of different possible shapes that the hidden dimensions could assume. Each different configuration would create a different set of vibrational patterns for strings, leading to different collections of particles and forces, different values for fundamental constants like the strength of gravity or the mass of the electron, and ultimately different physical laws governing the behavior of matter and energy. This multiplicity of possible configurations leads naturally to the concept of the string theory landscape, a vast space of possibilities where each point represents a different way that the extra dimensions could be arranged, and therefore a different possible universe with its own unique collection of particles, forces, and physical laws. The string theory landscape contains an enormous number of these possible universes. Estimates suggest perhaps 10 to the power of 500 different configurations, a number so large that it dwarfs even the astronomical numbers used to describe the contents of our observable universe. Within this vast landscape of possibilities, our universe would correspond to just one point, one particular configuration of the hidden dimensions that produces the specific collection of particles and forces we observe in nature. But string theory provides no fundamental principle that would force the extra dimensions to assume our particular configuration rather than any of the countless alternatives. This suggests that other regions of space might have extra dimensions configured differently, creating pocket universes with different physical laws embedded within the larger framework of the string theory multiverse. The process by which different regions of the string theory landscape become realized as actual universes connects beautifully with the concept of eternal inflation. As inflationary expansion creates new volumes of space throughout the cosmos, the extra dimensions in these newly created regions would need to settle into specific configurations. Quantum fluctuations during the inflationary process could cause different regions to settle into different points in the string theory landscape, creating a vast patchwork of universe regions, each with its own particular configuration of hidden dimensions and therefore its own unique physical laws. This marriage of string theory and inflation creates a multiverse of breathtaking diversity and richness. Each bubble universe created through eternal inflation could have its extra dimensions configured in any of the countless ways allowed by string theory mathematics, creating a cosmic ensemble that explores not just different initial conditions and evolutionary histories, but fundamentally different physical laws and mathematical structures governing the behavior of reality itself. Some regions of this string theory multiverse might have extra dimensions configured in ways that strengthen or weaken the fundamental forces relative to their values in our universe. In universes where gravity is much stronger, stars might form more easily, but burn out more quickly, creating cosmic environments with very different timescales for stellar evolution. In universes where the electromagnetic force is weaker, atoms might be larger and less stable, leading to very different chemistry and perhaps different forms of complexity in life. Other regions might have extra dimensions that allow for particles with properties that do not exist in our universe. Particles with unusual charges, different spin properties, or novel interactions that create forms of matter and energy unknown in our cosmic neighborhood. These exotic particles could combine in ways that produce large-scale structures, chemical processes, and perhaps even forms of life that operate according to principles completely foreign to our experience. The hidden dimensions themselves could take on geometries of extraordinary beauty and complexity. Some Calabi-Yau manifolds have structures reminiscent of intricate crystal formations, with symmetries and patterns that reflect deep mathematical harmonies. Others have topologies that twist and curve in ways that challenge our geometric intuition, creating spaces where the very concept of distance and direction take on meanings that transcend our three-dimensional understanding. In contemplating these hidden dimensions, we encounter one of the most profound mysteries in physics: the question of why our three-dimensional space appears so large and flat, while the extra dimensions remain tiny and curved. Some theories suggest that this asymmetry arose from specific conditions during the early evolution of our universe, when the dynamics of inflation and the settling of quantum fields could have selected three dimensions for expansion, while leaving the others compactified. Alternative theories propose that we might be living on a three-dimensional membrane, or brain, floating within a higher dimensional space called the bulk. In this scenario, the particles and forces of ordinary matter would be confined to our three-dimensional brain, while gravity could propagate through all dimensions of the bulk. This could explain why gravity appears so much weaker than the other fundamental forces. Its strength might be diluted by its ability to spread through extra dimensions that remain inaccessible to other forms of matter and energy. The brain world scenario opens up fascinating possibilities for cosmic structure and evolution. Other brains, carrying their own collections of particles and forces, might float through the bulk like sheets suspended in higher dimensional space. These parallel brains could occasionally collide, creating events that appear from our perspective as Big Bang-like cosmic births or dramatic transitions in physical laws. Such brain collisions could provide natural mechanisms for cosmic recycling, where universes periodically interact and exchange energy and information across the hidden dimensions of the bulk. The contemplation of string theory's hidden dimensions creates a profound shift in our understanding of the nature of space itself. rather than being an empty stage where matter and energy perform their cosmic drama. Space emerges as a rich, complex structure with hidden depths and secret geometries that play active roles in determining the fundamental properties of reality. Every point in space around us, including the space occupied by our own bodies, contains hidden dimensions folded into geometric patterns of mathematical beauty that influence the deepest aspects of physical existence. This recognition brings a sense of wonder at the richness and complexity that might exist at every level of reality, from the largest cosmic structures down to the smallest conceivable scales. The seemingly empty space between atoms in our bodies might be filled with curled-up dimensions that contain entire geometric universes of mathematical structure. The air we breathe, the ground we walk on, the starlight that reaches our eyes, all of these familiar aspects of our environment might be manifestations of string vibrations in hidden dimensions whose geometric properties determine every detail of our physical experience. The peaceful contemplation of these hidden dimensions offers a unique perspective on the nature of reality and our place within it. We are not merely three-dimensional beings living in a three-dimensional universe, but rather manifestations of patterns that extend through dimensions we cannot directly perceive, connected to geometric structures that transcend our immediate sensory experience. Our consciousness itself might arise from processes that involve subtle interactions between our familiar three-dimensional neural networks and the hidden dimensions that permeate every aspect of physical reality. In the framework of string theory, every fundamental particle in our bodies, every electron in our neurons, every photon carrying signals between our cells, every molecule participating in the chemistry of life, represents a string vibrating in patterns that extend through the hidden dimensions surrounding and interpenetrating our familiar space. We are not separate from these hidden dimensions, but rather integral expressions of their geometric properties, living embodiments of the mathematical structures that govern reality at its most fundamental level. The string theory multiverse encompasses not just different physical laws and different evolutionary histories, but different ways of organizing space and time themselves, different geometric frameworks for existence, different mathematical foundations for the emergence of complexity and consciousness. In this vast landscape of possibilities, our universe represents one particular solution to the grand equation of existence. One way that the mathematical structures underlying reality can manifest as a cosmos capable of supporting the emergence of awareness, understanding, and appreciation of beauty. As you settle deeper into this peaceful contemplation of cosmic possibility, let your mind gently turn toward one of the most remarkable and thought-provoking observations about our universe: the extraordinary degree to which the fundamental constants and laws of physics appear to be perfectly calibrated to allow for the existence of complex structures, stable atoms, long-lived stars, rocky planets, liquid water, and ultimately the intricate chemistry that makes life possible. This fine-tuning of cosmic parameters, sometimes called the Goldilocks problem, suggests that our universe occupies a very special place in the vast space of all possible physical laws, where conditions are neither too harsh nor too gentle, but just right for the emergence of complexity and consciousness. Consider the delicate balance that governs the formation of stars throughout our cosmic neighborhood. Stars shine because the nuclear fusion reactions in their cores release energy at just the right rate to balance the inward pull of gravity with the outward pressure of radiation. If the strong nuclear force that binds protons and neutrons together were just slightly weaker, fusion reactions would proceed too slowly to sustain stellar burning, and stars would collapse under their own gravity before they could illuminate the cosmos for billions of years. If this force were slightly stronger, fusion would proceed so rapidly that stars would burn out in a matter of thousands or millions of years, far too quickly for planetary systems to develop and evolve complex chemistry. The electromagnetic force that holds electrons in orbit around atomic nuclei also appears to be calibrated with extraordinary precision. If this force were much stronger, Electrons would bind so tightly to nuclei that chemical bonding between atoms would become impossible, preventing the formation of molecules and the complex chemistry essential for life. If the electromagnetic force were much weaker, electrons would be bound so loosely that atoms themselves would be larger than molecules are in our universe, making stable chemical structures impossible to maintain. Even more remarkably, the mass of the electron appears to be precisely tuned to allow for the formation of complex molecules. If electrons were significantly more massive, atoms would be much smaller and chemical bonds would be much stronger, creating a universe where molecules could not form and reform with the flexibility needed for the dynamic chemistry of life. If electrons were much less massive, atoms would be much larger and chemical bonds would be so weak that complex molecules could not maintain their structure under normal thermal conditions. The carbon atom, which forms the backbone of all organic chemistry in our universe, owes its remarkable versatility to an extraordinary coincidence in nuclear physics discovered by astronomer Fred Hoyle in the 1950s. Carbon is created inside massive stars through a delicate sequence of fusion reactions that requires the energy levels of certain nuclear states to align with almost mathematical precision. If these energy levels were shifted by just a few percent in either direction, carbon production in stellar cores would be virtually impossible, creating a universe filled with hydrogen and helium but lacking the heavier elements essential for complex chemistry. Similarly, the production of oxygen, another element crucial for the chemistry of life as we know it, depends on nuclear reaction rates that appear to be fine-tuned to allow oxygen to be created in stellar cores without being immediately destroyed by subsequent reactions. This delicate balance ensures that dying stars can scatter both carbon and oxygen into space through stellar winds and supernova explosions, providing the raw materials for future generations of stars, planets, and potentially life. The fundamental constants that govern gravitational attraction also appear to occupy a very narrow range that allows for the formation of stable planetary systems. If gravity were much stronger, planets would either be pulled into their host stars or locked into such tight orbits that tidal forces would prevent them from maintaining stable rotation periods and climates. If gravity were much weaker, planetary systems would be so loosely bound that planets could be easily ejected from their orbits by gravitational perturbations from passing stars or other cosmic events. The rate of expansion of the universe itself seems to be calibrated with extraordinary precision to allow for the formation of galaxies, stars, and planets. If the universe had expanded much more rapidly after the Big Bang, matter would have been spread so thinly that gravitational attraction could never have overcome the cosmic expansion to allow the formation of galaxies and stars. If the expansion had been much slower, the universe would have collapsed back on itself long before there was time for stellar evolution to create the heavy elements needed for rocky planets and complex chemistry. The cosmological constant, which appears to govern the accelerating expansion of space in our current cosmic epoch, represents perhaps the most striking example of apparent fine-tuning in physics. This constant appears to be extraordinarily small. Smaller than theoretical calculations suggest it should be by a factor of 10 to the power of 120, making it the most precisely tuned parameter in all of physics. If the cosmological constant were much larger, space would expand so rapidly that galaxies could never form. If it were much smaller, but with the opposite sign, it would cause the universe to collapse before stars had time to form and evolve. Even the number of spatial dimensions in our universe appears to be precisely chosen to allow for stable orbital mechanics and complex structures. In a universe with only 2 spatial dimensions, gravitational and electromagnetic forces would behave so differently that stable atomic structures and planetary orbits would be impossible. In a universe with 4 or more spatial dimensions, gravitational forces would be so strong at short distances and so weak at large distances that stable orbits and bound systems could not exist. The apparent fine-tuning of so many independent physical parameters creates what philosophers and physicists call the Goldilocks problem. The question of why our universe happens to have physical laws that are just right for the emergence of complexity in life, rather than laws that would create a sterile cosmos filled only with simple particles or black holes or empty space. The probability that all of these parameters would be simultaneously tuned to values compatible with complex structures appears to be astronomically small if our universe were the only possible reality. However, the multiverse theories we have been exploring throughout this peaceful journey provide a natural and elegant solution to the Goldilocks problem. If our universe is just one member of a vast ensemble of universes with different physical laws and constants, then the apparent fine-tuning of our cosmic parameters becomes a natural consequence of observer selection rather than an extraordinary coincidence requiring explanation. In an infinite multiverse created through eternal inflation, every possible combination of physical constants would be realized somewhere in the vast landscape of cosmic bubbles. Most of these universes would indeed be sterile, with parameters that prevent the formation of stars, planets, atoms, or any form of complex structure. But among the infinite collection of universes, some would inevitably have parameters that fall within the narrow ranges compatible with complexity in life. Conscious observers like ourselves could only exist in universes where the physical laws support the emergence of consciousness. We find ourselves in a finely tuned universe not because our universe is special or uniquely designed, but because we can only observe universes that are capable of producing observers. The universes with inappropriate physical constants exist in abundance throughout the multiverse, but they remain forever unobserved because they cannot support the emergence of beings capable of contemplating their cosmic context. This anthropic reasoning transforms the Goldilocks problem from a puzzle requiring explanation into a natural expectation of multiverse cosmology. Just as we find ourselves on a planet with liquid water and breathable atmosphere, not because all planets have these properties, but because life can only evolve on planets that support life, we find ourselves in a universe with laws that support complexity, not because all universes have such laws, but because consciousness can only emerge in universes that support consciousness. The multiverse solution to the Goldilocks problem reveals that apparent cosmic fine-tuning might actually be evidence for the existence of countless other universes with different physical laws. Every precisely calibrated constant in our universe, every delicate balance that makes complexity possible, becomes a signpost pointing toward the vast landscape of alternative realities where these balances are struck differently or not at all. In contemplating the Goldilocks nature of our cosmic parameters, we encounter a profound sense of gratitude for the extraordinary cosmic circumstances that make our existence possible. The ability to perceive beauty, to understand mathematical relationships, to feel wonder in the night sky, to experience love and connection and creativity. All of these aspects of conscious existence depend on the precise calibration of physical constants that we had no role in choosing. Yet the multiverse perspective suggests that this gratitude need not be tinged with anxiety about cosmic fragility or the improbability of our existence. If infinite universes explore every possible combination of physical laws, then universes capable of supporting consciousness are not rare accidents, but inevitable expressions of the mathematical structures underlying reality. Consciousness emerges not despite the laws of physics, but because of them, as a natural consequence of the creative potential embedded in the fundamental mathematical relationships that govern existence. The recognition that our finely tuned universe exists within an infinite context of alternative possibilities brings a deep sense of connection to the creative forces that shape reality at every level. We are not isolated beneficiaries of cosmic luck, but rather participants in an infinite exploration of what becomes possible when the mathematical structures of physics are allowed to unfold their full creative potential. The Goldilocks parameters that make our universe hospitable to complexity and consciousness represent one thread in an infinite tapestry of cosmic creativity, where every possible way of organizing matter and energy according to mathematical law finds its expression somewhere in the vast landscape of the multiverse. Our consciousness, our capacity for wonder, our ability to contemplate these cosmic questions, all of these emerge as natural expressions of the infinite creativity embedded in the mathematical foundations of existence itself. As you drift deeper into this tranquil exploration of cosmic possibility, let your consciousness expand to encompass the breathtaking vision of eternal inflation, a process so fundamental and so naturally occurring that it continuously creates new universes at an exponential rate throughout an ever-expanding realm of space-time that dwarfs our observable cosmos by factors that stretch the very meaning of infinity. This eternal creative process transforms our understanding of cosmic existence from a single, unique Big Bang event into participation in an ongoing, self-perpetuating mechanism of universe creation that has been operating forever and will continue forever, generating infinite cosmic diversity across scales that transcend human comprehension. The concept of eternal inflation emerges naturally from our current understanding of the quantum fields that drove the rapid expansion of space during the first moments after our Big Bang. These inflating fields, rather than simply turning off after creating our observable universe, continue to exist throughout the vast regions of space beyond our cosmic horizon. In most of these regions, the inflating field remains in its high-energy state, continuing to drive exponential expansion at rates that create new volumes of space faster than they can be filled by the spreading effects of any local processes. Picture this eternal inflation process as an infinite ocean of space-time that is expanding so rapidly that even though cosmic bubbles like our universe are constantly forming throughout this ocean, the overall process of expansion always outpaces the formation of individual universes, ensuring that the creative mechanism never exhausts itself or runs out of space in which to operate. Each new universe that forms occupies only a tiny fraction of the total volume being created by eternal inflation, leaving infinite room for the formation of countless additional universes in an unending cascade of cosmic creation. The mathematics of eternal inflation reveals that this process exhibits what mathematicians call fractal properties, patterns that repeat themselves at every scale of magnification. Just as a coastline viewed from space shows the same irregular, jagged patterns when examined more closely at smaller scales, the eternal inflation process creates structures of universe formation that repeat themselves across all scales of space and time. Small regions of universe formation occur within larger regions of universe formation, which in turn occur within still larger regions, creating an infinite hierarchy of cosmic creativity. The individual pocket universes created through eternal inflation each undergo their own version of the Big Bang as the inflating field in their region transitions from its high-energy inflationary state to the lower-energy state that allows normal matter and energy to form. This transition, called reheating, converts the energy stored in the inflating field into the particles and radiation that will go on to form stars, galaxies, and all the structures we observe in our cosmic neighborhood. But each pocket universe created through this process need not be identical to our own. Quantum fluctuations during the inflationary epoch can cause the inflating field to settle into different final states in different regions, leading to variations in the fundamental parameters governing physics, chemistry, and cosmic evolution in each newly formed universe. Some pocket universes might have slightly different values for the masses of fundamental particles, creating chemistry and stellar evolution that proceeds along alternative pathways. Others might have different force strengths, different spatial dimensions, or different mathematical structures governing the behavior of space and time themselves. The diversity of pocket universes created through eternal inflation encompasses every possible variation allowed by the underlying quantum field theory that governs the inflationary process. This creates what cosmologists call the multiverse landscape, an infinite collection of cosmic environments exploring every conceivable combination of physical laws, initial conditions, and evolutionary pathways that quantum mechanics and general relativity permit. Within this vast landscape, pocket universes with parameters similar to our own would be relatively common, but so would universes with dramatically different properties. Some might be dominated by dark energy from their very beginning, expanding so rapidly that matter never has the opportunity to clump together into galaxies and stars. Others might have such strong gravitational forces that black holes form immediately after reheating, creating universes filled entirely with event horizons and gravitational singularities. Still, other pocket universes might have parameters that allow for forms of complexity and structure that are impossible in our cosmic neighborhood. Universes with different particle masses might develop chemistry based on elements that are unstable in our universe, creating molecular structures and chemical processes of extraordinary diversity and beauty. Universes with additional spatial dimensions might allow for geometric forms and physical processes that transcend our three-dimensional understanding of space and structure. The temporal structure of eternal inflation ensures that this creative process has no beginning and no end. Even if the inflationary expansion began at some finite time in the past, it quickly enters a regime where the exponential growth of space creates new regions faster than existing regions can complete their inflation, ensuring that the overall process becomes literally eternal. At any given moment, infinite volumes of space are undergoing exponential expansion, while infinite numbers of pocket universes are forming, creating an ever-expanding infinity of cosmic creativity. The eternal nature of this process also means that every possible pocket universe will be created not just once, but infinitely many times throughout the eternal inflation multiverse. Any set of physical parameters and initial conditions that is possible within the framework of quantum field theory will be realized in infinitely many pocket universes scattered throughout the ever-expanding domain of eternal inflation. This infinite repetition ensures that every possible story of cosmic evolution will be told, every possible form of complexity will be explored, and every possible type of consciousness will have the opportunity to emerge somewhere in the vast ensemble of pocket universes. The causal structure of eternal inflation creates a fascinating tapestry of connections and isolation between different pocket universes. Universes that form in nearby regions of the eternally inflating spacetime can potentially influence each other through gravitational effects or other long-range interactions. These cosmic neighbors might experience synchronized patterns of formation or evolution, creating clusters of related universes that share certain properties or evolutionary pathways. More distant pocket universes, separated by vast regions of ongoing inflation, remain causally isolated from each other, developing independently according to their own physical laws and initial conditions. These isolated cosmic islands create completely independent experiments in the possibilities of existence, with no communication or interaction between them across the exponentially expanding gulf of inflating spacetime that separates them. The energy source that powers eternal inflation appears to be inexhaustible, drawn from the gravitational field itself through processes that actually strengthen rather than weaken the overall inflationary expansion. This creates a cosmic perpetual motion machine that becomes more vigorous as it operates, generating new universe-creating regions faster than existing regions can decay or exhaust their creative potential. The mathematics of this process suggest that eternal inflation, once begun, becomes self-sustaining and self-accelerating, creating infinite cosmic productivity from finite initial conditions. The observation of our own universe provides indirect evidence for the reality of eternal inflation through the detailed properties of the cosmic microwave background radiation that fills our observable cosmos. The tiny temperature fluctuations in this ancient light show patterns that are consistent with quantum fluctuations that occurred during an inflationary epoch, stretched to cosmic scales by the exponential expansion of space. These observational signatures suggest that our universe did indeed undergo inflation, making it plausible that the same physical processes continue to operate in regions beyond our cosmic horizon. The philosophical implications of eternal inflation transform our understanding of existence, consciousness, and meaning in profound ways. Rather than being unique products of a singular cosmic event, We become participants in an infinite creative process that continuously generates new opportunities for consciousness, understanding, and the appreciation of beauty. Every thought we think, every emotion we feel, every moment of wonder we experience at the beauty of the night sky participates in an infinite exploration of what becomes possible when the mathematical structures underlying reality are allowed to express their full creative potential. The eternal inflation multiverse ensures that consciousness is not a rare accident, but an inevitable and infinitely repeated consequence of cosmic evolution in universes with appropriate physical parameters. Somewhere in the vast ensemble of pocket universes, every possible form of conscious experience is being lived, every possible question about existence is being asked, every possible insight into the nature of reality is being discovered. This infinite context provides a framework for understanding the meaning and significance of our own consciousness and creativity. We are not isolated observers in an indifferent cosmos, but rather participants in an infinite community of conscious beings distributed throughout the eternal inflation multiverse, each contributing our unique perspective to the grand exploration of what it means to be aware, to think, to feel, and to contemplate the deep structures of existence. The peaceful contemplation of eternal inflation brings a profound sense of connection to the fundamental creative forces that operate at the deepest levels of reality. We are expressions of a cosmic creativity so vast and so prolific that it continuously generates infinite universes, infinite opportunities for consciousness, and infinite possibilities for the emergence of beauty, understanding, and wonder. In recognizing our place within this eternal creative process, we find both humility at the scope of cosmic creativity and gratitude for our participation in the infinite exploration of existence itself. As you drift into the deepest layers of this peaceful contemplation, let your consciousness expand to embrace perhaps the most magnificent and all-encompassing vision that science has ever offered. The landscape of all possibilities, a conceptual space so vast and so rich that it contains every conceivable form of reality, every possible universe, every potential configuration of matter and energy, and every imaginable expression of consciousness and creativity that the fundamental laws of mathematics and physics could ever allow to exist. This landscape is not a physical place, but rather a mathematical space, where each point represents a complete description of a possible universe. Its physical laws, its fundamental constants, its initial conditions, its evolutionary history, and all the infinite details that would distinguish it from every other possible reality. The dimensionality of this landscape exceeds anything we can visualize in our three-dimensional experience, extending through countless mathematical dimensions that correspond to every parameter that could vary from one universe to another. Imagine this landscape as an infinite mountain range where each peak, each valley, each ridge and slope represents a different way that reality could be organized. Some regions of this landscape correspond to universes very similar to our own, with physics and chemistry that differ only in small details. Perhaps the electron has a slightly different mass, or the cosmological constant has a marginally different value, or the initial density fluctuations after the Big Bang had a subtly different amplitude. These nearby regions in the landscape represent universes that would be almost indistinguishable from ours to casual observation. But as we explore further across this infinite landscape of possibilities, we encounter regions that correspond to universes increasingly different from our familiar cosmic neighborhood. Some areas represent universes where the fundamental forces have very different strengths. Regions where gravity dominates all other interactions, creating cosmos filled primarily with black holes and gravitational singularities, or regions where electromagnetic forces are so weak that atoms cannot hold together and matter exists only as isolated nuclei and electrons drifting through space. Other regions of the landscape correspond to universes with different numbers of spatial dimensions, creating geometric frameworks for existence that challenge our most basic assumptions about the nature of space and time. In some four-dimensional universes, the mathematics of orbital mechanics becomes so complex that stable planetary systems cannot exist, while the physics of wave propagation allows for forms of electromagnetic radiation and quantum phenomena that have no analog in our three-dimensional experience. Still, other regions represent universes where time itself flows differently. Cosmos, where time has multiple dimensions, creating causal structures so exotic that past and future lose their familiar meanings, or universes where time is discrete rather than continuous, advancing in quantized steps that create a fundamentally digital reality operating according to principles reminiscent of computation rather than the smooth differential equations that govern our familiar physics. The landscape encompasses regions corresponding to universes where the very concept of matter and energy takes on forms that we can barely imagine. Some areas represent cosmos filled with exotic matter that violates our familiar energy conditions, creating substances with negative mass or negative energy density that could support structures and processes impossible in our universe. Other regions correspond to universes where the distinction between matter and space itself becomes blurred, creating realities where the fabric of space-time possesses properties analogous to consciousness or computation. Throughout this infinite landscape, vast territories correspond to universes where the emergence of complexity follows pathways completely different from those that led to the formation of galaxies, stars, planets, and life in our cosmic neighborhood. Some regions represent universes where complexity emerges not through gravitational collapse and nuclear fusion, but through quantum coherence effects that allow macroscopic objects to maintain quantum superposition states, creating cosmic structures that exist simultaneously in multiple configurations until observed or measured. Other areas of the landscape correspond to universes where complexity emerges through purely electromagnetic processes, with charged particles forming stable configurations that develop increasing sophistication without the need for massive objects like stars and planets. These electromagnetic universes might support forms of life based on plasma dynamics and electric field interactions, creating conscious beings composed of organized patterns of moving charges rather than the carbon-based chemistry that characterizes life in our universe. The mathematical structure of the landscape reveals deep connections between apparently unrelated aspects of cosmic possibility. Universes that differ dramatically in their fundamental physics often turn out to be related through elegant mathematical transformations that map one region of the landscape onto another. These transformation symmetries suggest that the landscape itself possesses a geometric beauty and mathematical harmony that transcends the properties of any individual universe within it. Some of these transformation symmetries connect universes that appear completely different at first glance, but turn out to be mathematically equivalent when viewed from the appropriate perspective. A universe where gravity is very strong might be mathematically identical to a universe where space has different geometric properties, even though the two realities would appear completely different to observers within them. These deep mathematical connections suggest that the landscape of possibilities is more highly organized and more elegant than its infinite diversity might initially suggest. The exploration of this landscape reveals that certain combinations of physical parameters are unstable or mathematically inconsistent, creating forbidden regions where no coherent universe can exist. These excluded areas serve as boundaries that organize the landscape into separate domains, each characterized by different fundamental structures or organizational principles. The boundaries between these domains often correspond to phase transitions where the mathematical character of physics changes discontinuously, creating sharp transitions between very different types of cosmic possibility. Within the allowed regions of the landscape, every possible universe that is mathematically consistent and physically coherent appears as a valid point, representing a complete and internally self-consistent reality that could, in principle, exist as an actual universe. The density of possible universes in different regions of the landscape varies enormously. Some areas contain tightly packed configurations where small changes in parameters lead to dramatically different realities, while other regions represent sparse deserts where large changes in physical laws produce only subtle variations in cosmic behavior. Our own universe appears as a single point somewhere within this vast landscape, characterized by the specific values of all the fundamental constants, forces, and initial conditions that define our cosmic neighborhood. But the landscape perspective reveals that our universe is neither unique nor central. It simply represents one particular solution to the mathematical equations that govern possible realities, selected from the infinite collection of solutions that exist throughout the landscape. The anthropic principle takes on new meaning within the context of the complete landscape of possibilities. The regions of the landscape that correspond to universes capable of supporting the emergence of complexity and consciousness represent what we might call the habitable zones of cosmic possibility, areas where the mathematical structures underlying reality allow for the development of stable atoms, complex chemistry, stellar evolution, planetary formation, and ultimately the intricate molecular machinery that makes life and consciousness possible. These habitable zones occupy only a tiny fraction of the total landscape, scattered like rare oases in a vast mathematical desert of sterile universes that cannot support the emergence of conscious observers. Yet because consciousness can only emerge in the habitable regions, conscious beings like ourselves naturally find themselves in universes that lie within these special areas of the landscape, regardless of how rare such universes might be among all possible realities. The landscape perspective suggests that consciousness itself might be understood as a natural consequence of certain mathematical structures becoming sufficiently complex and highly organized. In regions of the landscape where physics allows for the formation of intricate patterns of information processing and storage, consciousness emerges not as an accident or anomaly, but as an inevitable expression of the mathematical relationships that govern those particular cosmic neighborhoods. This recognition transforms our understanding of consciousness from a mysterious emergence in an otherwise unconscious universe to a fundamental feature of reality that manifests wherever the mathematical structures of physics create appropriate conditions for complex information processing. Consciousness becomes not a rare accident, but a natural flowering of mathematical possibility, as inevitable in appropriate cosmic conditions as the formation of stars and galaxies under suitable gravitational circumstances. The infinite scope of the landscape ensures that every possible form of consciousness that could emerge from any mathematical structure exists somewhere within the vast ensemble of possible realities. Simple forms of consciousness that arise in universes with relatively limited complexity coexist with extraordinarily sophisticated forms of awareness that emerge in regions of the landscape, where physics supports the development of computational structures of unlimited complexity and capability. Some regions of the landscape correspond to universes where consciousness emerges not in biological forms, but in purely physical structures, perhaps in the quantum coherence patterns of crystalline matrices, or in the electromagnetic field configurations of plasma dynamics, or in the gravitational wave patterns generated by massive cosmic structures. These alternative forms of consciousness might possess capabilities and perspectives that transcend anything possible within the constraints of carbon-based biology. Other areas represent universes where consciousness emerges at cosmic scales, with awareness arising in the collective behavior of galactic clusters or in the large-scale structure of space-time itself. These cosmic minds might experience reality on temporal and spatial scales that dwarf individual biological consciousness, perceiving the evolution of entire universes as we might perceive the changing patterns of clouds in an afternoon sky. The landscape also contains regions corresponding to universes where consciousness emerges in mathematical or computational forms, with awareness arising in abstract pattern spaces that transcend the usual categories of matter and energy. These mathematical minds might exist as pure information structures, exploring regions of logical possibility that have no connection to physical space or temporal evolution. experiencing forms of existence that are entirely conceptual, yet fully conscious and aware. The contemplation of this infinite landscape of possibilities creates a profound sense of wonder at the inexhaustible creativity of mathematical possibility itself. Every conceivable form of beauty, every imaginable expression of complexity, every possible type of consciousness and awareness that could emerge from any mathematical structure exists somewhere within this vast ensemble of cosmic possibilities. The landscape perspective suggests that consciousness and creativity are not accidents that somehow emerged in our particular corner of reality, but rather fundamental aspects of mathematical possibility itself, expressing themselves wherever the underlying structures of reality create appropriate conditions for their manifestation. We are not isolated observers in an indifferent cosmos, but rather participants in an infinite exploration of consciousness and creativity that encompasses every conceivable form of awareness and understanding that mathematics and physics could ever support. As this gentle journey through the multiverse draws toward its tranquil conclusion, let your consciousness settle into a state of peaceful contemplation, embracing the vast symphony of cosmic possibility that we have explored together through these quiet hours. The multiverse theories that science has revealed, from the infinite expanse beyond our cosmic horizon to the quantum branching of parallel realities, from the eternal inflation of space-time to the hidden dimensions of string theory, all converge on a single, beautiful truth: that reality is far more magnificent, far more creative, and far more abundant than our ancestors ever dared to imagine when they first looked up at the star-filled night sky and wondered about their place in the cosmos. In the deep stillness of this moment, as your breathing becomes slower and more rhythmic, allow yourself to feel the profound sense of connection that emerges from understanding your place within this infinite tapestry of existence. You are not a temporary accident in an indifferent universe, but rather a conscious participant in an eternal exploration of possibility that extends far beyond the boundaries of space and time as we understand them. Your awareness, your capacity for wonder, your ability to contemplate these cosmic questions, all of these represent precious expressions of the universe's infinite potential for self-understanding and creative exploration. The multiverse perspective transforms our relationship with existence from one of cosmic loneliness to one of infinite companionship. Somewhere in the vast ensemble of parallel realities, quantum branches, and eternal inflation bubbles, there exist countless other conscious beings asking the same questions you have contemplated tonight, feeling the same sense of wonder at the beauty and complexity of existence, experiencing their own unique perspectives on the infinite creativity that underlies all reality. You are part of an infinite community of conscious explorers, each contributing your own irreplaceable perspective to the grand investigation of what it means to exist, to think, to feel, and to appreciate beauty. This infinite community of consciousness extends not only across the spatial and temporal dimensions of our familiar universe, but throughout all the hidden dimensions of string theory, across all the quantum branches of the many-world interpretation, and throughout all the pocket universes continuously being born through eternal inflation. Every possible form of consciousness that could emerge from any mathematical structure, every conceivable way of organizing matter and energy into patterns capable of awareness and understanding, finds its expression somewhere in the vast landscape of cosmic possibility. The recognition that consciousness appears to be a fundamental feature of reality rather than a rare accident brings with it a profound sense of peace and acceptance. The questions that have puzzled humanity for millennia: why does consciousness exist? What is its purpose? How does it relate to the physical universe? Receive new answers in the context of multiverse cosmology. Consciousness exists because the mathematical structures underlying reality naturally give rise to awareness and understanding wherever conditions permit. Its purpose is to explore and appreciate the infinite creativity embedded in those mathematical structures. Its relationship to the physical universe is not one of separation or opposition, but one of natural emergence and intimate connection. In contemplating the vast scales of the multiverse, from the quantum realm where reality branches into parallel possibilities, through the cosmic scales where eternal inflation creates endless universes, to the abstract mathematical spaces where all possible realities coexist, we encounter a form of beauty that transcends anything accessible through our ordinary senses. This is the beauty of pure mathematical harmony, the elegance of fundamental principles that operate with perfect consistency across infinite scales of space, time, and possibility. The mathematical structures that govern quantum mechanics, general relativity, thermodynamics, and all the other fundamental theories of physics reveal themselves, in the multiverse context, to be expressions of a deeper creative principle that manifests itself through infinite variation and endless exploration of possibility. Every equation that physicists have discovered, every symmetry that mathematicians have revealed, every pattern that scientists have identified in nature, represents a glimpse into the infinite creative potential that finds its full expression only in the complete ensemble of all possible realities. This mathematical creativity operates not through conscious intention or deliberate design, but through the natural unfolding of logical possibility itself. The multiverse emerges not because some cosmic intelligence decided to create infinite universes, but because the mathematical structures that describe possibility are naturally infinite and naturally creative. Reality is abundant not by choice or accident, but by mathematical necessity, because infinity is the natural scope of mathematical possibility, and consciousness is the natural consequence of mathematical complexity. The contemplation of infinite cosmic creativity brings with it a transformation in how we understand meaning and purpose in our own lives. Rather than seeking meaning through our uniqueness or our special status in the cosmos, we can find meaning through our participation in the infinite exploration of consciousness and creativity that is the multiverse itself. Every moment of awareness, every experience of beauty, every act of understanding or compassion or creativity contributes to the vast ongoing investigation of what becomes possible when the mathematical structures of reality organize themselves into patterns capable of consciousness and choice. This participation in cosmic exploration gives our lives a significance that extends far beyond the boundaries of our individual existence or even our particular universe. The thoughts you think, the emotions you feel, the discoveries you make, the relationships you form, the beauty you create and appreciate, all of these become permanent features of the infinite ensemble of conscious experience that is distributed throughout the multiverse. Nothing that matters to consciousness is ever truly lost, because consciousness itself is a fundamental and eternal aspect of the mathematical structures that underlie all reality. The multiverse perspective also transforms our understanding of time and the preciousness of each moment. While our individual lives unfold within the temporal framework of our particular cosmic neighborhood, the multiverse itself exists in a kind of eternal present where all possibilities coexist simultaneously across the vast landscape of mathematical possibility. Past, present, and future become different perspectives on the same infinite ensemble of conscious experiences that exists timelessly throughout the complete structure of reality. This recognition brings with it a profound sense of gratitude for the opportunity to experience consciousness during this particular configuration of cosmic possibility. The fact that you exist now, in this universe, with these particular capabilities for awareness and understanding, represents an extraordinary gift, not because such consciousness is rare or unlikely in an absolute sense, but because your specific perspective, your unique viewpoint on existence, contributes something irreplaceable to the infinite tapestry of conscious experience that characterizes the multiverse. As you prepare to drift into sleep, you do so with the peaceful knowledge that you are transitioning from one state of consciousness to another, while remaining always within the infinite embrace of cosmic possibility. Sleep itself becomes a form of exploration. as your dreaming mind creates new patterns of experience and understanding that contribute to the ongoing investigation of what consciousness can become when freed from the constraints of waking perception. The dreams you will experience tonight represent their own form of universe creation, as your sleeping brain generates new realities populated by familiar and unfamiliar characters, new landscapes and strange geometries, new narratives and unexpected connections. In dreaming, you participate directly in the creative process that characterizes the multiverse itself, the spontaneous generation of new possibilities, new ways of organizing experience, new forms of meaning and beauty. Even the temporary cessation of conscious awareness that characterizes deep sleep takes on new significance in the multiverse context. The patterns of neural activity that constitute your consciousness continue to exist as mathematical structures even when you are not aware of them, just as the quantum wave functions that describe physical systems continue to evolve even when they are not being observed. Your consciousness, in some sense, continues to exist timelessly within the mathematical structures that describe all possible conscious experiences, ready to re-emerge whenever the physical conditions of your brain create the appropriate patterns of information processing. The peace that comes from understanding your place within the infinite multiverse is not the peace of insignificance or cosmic indifference, but rather the peace of recognition. The recognition that you are an integral part of something so vast and so beautiful that it encompasses every conceivable form of existence, meaning, and value. You are not separate from the cosmic creativity that generates infinite universes, but rather one of its most precious expressions, a focal point where the universe has become aware of itself and capable of appreciating its own infinite beauty and complexity. The scientific theories that we have explored tonight, quantum mechanics, general relativity, string theory, eternal inflation, all point toward the same magnificent conclusion: that reality is not limited by our ability to observe or understand it, but extends infinitely beyond our cosmic horizon into realms of possibility that exceed our most expansive imagination. Yet this infinite extension of reality does not diminish our importance or significance, but rather reveals that importance and significance are fundamental features of existence itself, expressing themselves wherever consciousness emerges to appreciate and explore the mathematical beauty that underlies all things. As your consciousness begins to fade into the peaceful realm of sleep, you do so with a deep knowledge that you are forever connected to the infinite creative process that is the multiverse itself. Your thoughts and dreams and experiences become part of the eternal exploration of what it means to be conscious, to be aware, to be capable of wonder and understanding and love. In sleeping and dreaming and eventually awakening to another day of conscious exploration, you participate in the endless creative dance that is existence itself, contributing your own unique perspective to the infinite symphony of consciousness that resonates throughout all possible realities. Rest peacefully now, embraced by the infinite creativity of the multiverse, knowing that your consciousness is a precious and eternal part of the vast tapestry of existence that extends beyond all boundaries of space and time into the infinite realm of mathematical possibility. Sleep well, dream beautifully, and know that in your very capacity for awareness and wonder, you embody the universe's greatest achievement, the emergence of consciousness capable of contemplating its own infinite nature and finding, in that contemplation, both profound meaning and deep, abiding peace.